Hi, Elaine again. I just wanted to post an additional video to accompany my SCEC 2020 poster, number 19. And this video is going to show the details of the line work for the different mappers at a more dynamic view than you get just looking at the poster. Okay, so starting out, just to give us some context, this is the outline of California, and this gray blob here with red lines is the location of the Ridgecrest LiDAR. I'm going to zoom in there now. This faint green box is the outline of the area analyzed on the poster. And right now what you're looking at are red lines from the Ponte et al. Maps. I'm going to now go ahead and turn those off and turn on the lines from the authors of the posters mapping, and zoom in and just show you some of the details and the differences of how the three different mappers mapped areas. So down in this southeast corner of our map area for the poster, it's kind of complicated because the Rupture cuts through a place with a lot of paleo shorelines. And so determining what's a fault scarp and what's a paleo shoreline from the LiDAR is not always super straightforward. And so there's quite a bit of variability across the three mappers in terms of how they handled this location. Turn off the hillshade so you can see a little bit more of that variability. And so this would be a source of disagreement in our analysis, which is quite different from looking at this part of the Rupture, where if we look at the hillshade, I'm going to switch to the rotated sun hillshade. Oops, not that one, this one. So the Rupture is pretty discrete through here. It's a narrow zone with easy to pick out fault scarp or scarp, Rupture scarp. And so you can see that the three lines from each of the mappers fall pretty close together along that feature. The way that different mappers handle stepovers varies as well. So again, like this kind of area, I'm going to move a little bit further up along the Rupture to the location shown in the preferred visualization section of the poster. So this is the extent of map A, or roughly the extent of map A. So this is what it looks like on the rotated sun hillshade. And then I'm going to just take that away so you can see the line work more easily. And again, in the places where it's easier to pick out on the LiDAR, the lines are close together. And then in the sort of stepovers or places where the lines aren't, or the Rupture isn't as continuous, there's more variability. As we go even further up, this is getting into the location of map B. And just to show it with the hillshade real quick. Again, this is the rotated sun. And so this is an area where the Rupture is breaking through less consolidated sediments. And there's quite a bit of variability in how each of the authors interpreted this section. And so just to zoom back out so you can get the kind of big picture view one more time. This is the area presented on our map. Here it is with just mapper 1 lines. Mapper 2 lines. Mapper's 3 lines. Here are the lines from Duras et al. 2020. And here are the lines from Ponte et al. 2020.